All right, today is our first lesson for chapter 4. It's on polynomials. Okay, so our objectives are going to be identify what polynomial functions are, and then we're going to sketch them based on the zeros, degree, leading coefficient, things like that. And then we're going to write the polynomial functions from the graphs. Okay, so this lesson is basically jam-packed with a lot of information. You guys really want to take notes, write down things. If you hear something new, write it down, okay? Because you're gonna miss them. So the definition of a polynomial is, so this is the form of the polynomial, right? It looks something like this, um, where all the a's, okay, all these a's are the coefficient and they're constant, and the n's, which are the exponents here, have to be whole numbers larger than zero, okay, integers larger than zero. So it looks all crazy, but when you get an actual example, it's not that bad, okay? So all it means is that um, the exponents have to be whole numbers and they have to be positive. That's all we really want to look for. Okay, so let's look at some examples here. The first one, A, is this right here, and is it a polynomial or not? See, you look at all the exponents on x. This is 3, this is 2, so yes, it is a polynomial. Okay, well, look at this one. Again, it is a polynomial because the exponent on x is here is 1, here is 4. So yes, it is a polynomial, but we really want to move this around because we want the largest exponent to be in front, right? So it actually should look like this. Negative 3x to the fourth goes first. And then you have x, and then you have 2. This one, the square root of x, that is actually not a polynomial function because the exponent on x is actually 1/2, right? Square root is 1/2 in form of exponent. So that's what it is. Here, d, this one is, oh, by the way, that's a no. This one is not a polynomial function because you have this x here has a negative exponent, right? It's at the bottom of a fraction, so it's a negative exponent. Okay, e, surprisingly, that is a polynomial function. So some of you guys might be like, well, it doesn't have any x. So all these, so all the a's in front here are just 0. So basically, it's 0x to the whatever power. And it just has an 8 left. That's the a sub 0. That's the last one, the constant. Okay, so that is a polynomial function. This one here is also a polynomial function because all the x have positive whole number exponents. So some more definitions here. The leading term is the term with the highest degree. So it's going to be this guy, right? The guy in front where n is the largest one. Okay. So that is the leading term. The degree of the polynomial is n, which is the exponent of the leading term. So the largest exponent is the degree. So there's that n right there. And the leading coefficient is the coefficient in front of the x with the largest exponent, which is a sub n. That one right there. Okay. So here is an example. Here the degree is 3 because that's the largest exponent, and the leading coefficient is 5. For this one, remember we rewrite that as this. So leading coefficient, I mean the leading term is the guy in the back here because it has the largest exponent, not necessarily the one in front, but the one with the largest exponent. So our degree is 4, and our leading coefficient is negative 3. And here is just a constant. Now the degree is 0 because x sub 0, right? I mean x to the 0 power, and the leading coefficient is 8. This one, imagine that you multiply this out. This is important. You guys have to visualize multiplying this out. So I have basically x minus 1 times x minus 1. That gives me like this. So you have x squared plus whatever in the back. Because I don't care about what's in the back. I only care about the leading coefficient. So I only need to know the first one, right? So I get the first term, and I don't care about the back. And then I multiply this in, and that'll give me the leading coefficient and the leading term. So I have negative 2x to the fifth plus whatever in the back. And so that is my leading term. So my degree is 5, and my leading coefficient is -2. Now, what does the degree and the coefficient tells you? So this box here is for like a positive coefficient and an odd degree. And this is for a positive coefficient and an odd even degree. So for degree, you care about whether it's odd or even. And for coefficient, you want to know whether it's positive or negative. Okay. Now, the easiest thing to remember is if it's negative. If it's negative, the right side points down. And if it's positive, the right side points up. So the graph has a right side and a left side. If it's positive, the right side points up, and the negative, the right side points down. So the right side always corresponds with the sign of the leading coefficient. Okay, again, if the sign is positive, the right side points up. If it's negative, the right side points down. The left side, not necessarily. The left side depends on the right side. And that's where the degree comes in. If it's odd degree, then they point in opposite direction. So if this one is going up, then this one has to go down, right? If this one points up, but this one is even, so they go the same direction. If this one points up, then the left side points up also. Oh, that's out of order. Anyways, so that's everything right here. Okay, so I'm gonna go over this one more time because it's confusing. Again, if it's positive, the right side goes up. If it's negative, the right side goes down. The right side corresponds with the sign. Odd or even tells you whether the left side goes the same direction or opposite direction of the right side. So if it's odd, it goes opposite direction. If the right side goes up, it goes down. Right side goes down, it goes up. If it's even, it goes same direction. Right side goes up, it goes up. Right side goes down, it goes down. So some example here, I guess. Here is an example of this guy here. And the degree is 3, and the leading coefficient is 5, which is positive. So the degree is odd, positive coefficient. So odd means it goes opposite direction, and positive means the right side goes up. If right side goes up and it's opposite direction, so left side has to go down. So it looks something like this, right? Right side goes up, left side goes down. Again, positive means right side goes up. And then odd tells you the other side has to be opposite of it. Okay? Another one here. Here is the degree is 4, which is even, and the leading coefficient is negative. So negative means the right side has to go down. And since it's even, it means it goes the same direction on the other side. So it has to also go down. Now, the graph of a polynomial function has to be smooth and continuous. So these are the two words that describe them. They have to be smooth and continuous. There's no gap, and there is no corners and cusps, okay? But here, on this graph here, you guys notice here, the point that it touches the x-axis, these are called the zeros, right? Zeros. In this case, we call them real zeros because you can have imaginary ones. But the real zeros, our values are such that f of r is equal to 0. Basically means whatever number that you put in here, it makes f of x equal to 0. Basically called the x-intercepts. We know this already, right? You put the x-intercepts in, you get 0 for y. This is the example of something that is not a polynomial, right? Because it has corners and cusps. That means that it is not smooth, and it has gaps and holes. That means that it's not continuous. All right, so let's talk more about the zeros and multiplicity because these are really important. Multiplicity is the number of times a zero is repeated. For example, you have here, let's look at what kind of zeros there are, right? Zeros means you basically put a value in for x that makes this 0. So just set each of them equal to 0 and you can find the zeros, right? So for this one, x is equal to 0, right? X is equal to 0, and there's the exponent is 1, meaning the multiplicity is 1. This one here, the 0 is 3, right? Because 3 minus 3 is 0. And the multiplicity is 2 because of the exponent there. Okay. And then the last one, the 0 is -5, and the multiplicity is 3 from this one. And these are some really important notes on multiplicity, so write this down. If the multiplicity is odd, the graph crosses the x-axis. And if it's even, then the graph bounces off the x-axis. So for example, this x here is 0, multiplicity of 1. So let's see here. So let's just put this on the graph. My x-axis, or my 0 is at 0, 3, and -5. Okay. Now you look at the -5 here. The multiplicity is 3. It's odd, so the graph goes across. It crosses it. But if it's at 0 here, 0 is also an odd multiplicity, so it also crosses it, right? So it goes cross. However, if you look at 3, the multiplicity is 2. It's even, so it bounces off. So it goes like that. Okay. So let's sketch these graphs. Let's put them all together and practice this now. Here is a function. We're going to graph this. So what are the zeros? 1 for this one. Multiplicity of 1 because there's no exponent, right? Just exponent of 1. Same thing here, -1. And here's -3. All of them multiplicity of 1. Odd multiplicity. So they all cross. Okay, they don't bounce. But let's look at the degree. Degree is 3, right? Because if you multiply all the leading terms, you have x to the 3rd power. So it's odd. The leading coefficient is 1 because it's 1x times 1x times 1x. So it's just 1. So it's positive. Positive means the right side goes up. And odd means it's opposite, so the left side has to go down. But anyways, let's put in the 0. So I have 1, -1, and -3. All right, so the right side, positive, right side goes up. Odd, so the left side has to be opposite, so left side goes down. Now it crosses all of these, so it has to go over and come back down, right? Because I got to go come back down to cross this one, and I got to go back up to cross this one, like that. And that's basically the sketch of that graph. Here's another. So the zeros, here is the 0 of -1, multiplicity of 2, and the other 0 is at +2, multiplicity of 1 for the second one. And then the degree is odd because this is x squared, right? And times x is x cubed, is 3, degree is 3. And the leading coefficient is -1 because there's a negative in front. These are positives, but the negative right there makes it -1. So if it's negative, the right side goes down. But let's put the zeros in. I have -1 and 2. Okay, right side goes down because it's negative. Left side goes up because it's odd, so it has opposite direction. So left side goes up. Now, at -1, multiplicity of 2 means it bounces. So it goes down and bounces up like that. And then this one, at 2, it crosses. So it has to go down and cross over. The last thing you have to learn is how to write the polynomial function for the graph. So here you have the zeros. So you can write this out, right? The zeros at -2, at 0, and at 2. So -2, here it bounces off. So I'm going to assume that the multiplicity is 2. It could be 4, it could be 6, but they want the smallest degree. So I'm going to take 2. Okay, so it's even. We know for sure it's even. And I'm going to pick 2 for the smallest possible. This 0 here, it crosses, so multiplicity of 1. So x is 0, multiplicity of 1, and x is 2, multiplicity of 1. Okay, so again, if it bounces off, multiplicity is even. If it crosses, multiplicity is odd. All right, so here, x minus 2 means x plus 2 is a factor, right? And then that is your exponent. The multiplicity is the exponent. Here, x is equal to 0 means just x, and then exponent of 1. And x equals 2 means x minus 2, multiplicity of 1. But remember, we don't know what happens between the x-intercepts and how high, how low it goes. And that is determined by the letter A in front here. Okay, and then so they gave us a point. That means we can solve for A. Okay, if we don't have another point, we can't find it. There are many that looks like this, but it could go higher or lower, but cross the same x-axis, right? But this one in particular has -1, 6, so we can plug that in and solve for A. So I put 6 in for y and -1 in for x, and I solve for A like this. And so A comes out to be 2. So my function is f of x is equal to 2 times this.